So we're starting this study of geometry, and it's very important at the very beginning we need to get some key concepts down, as well as the notation that's associated with those concepts. This way we can speak the same language. So we're learning this language of math. And for example, when I talk about a point, when I say, okay, there is a point A, like right here, we got this point A. What am I talking about? Well, really, I'm talking about a location. You know, I could describe where you're standing. You're standing at point A or something like that. In other words, it doesn't have any dimensions to it. It's really just a theoretical idea. It's a point. Okay, so we start off just realizing, okay, if we talk about a point, like, for example, if we have a number line, we have 0, 1, and 2. I could say, okay, 2, that's a point. There's a point on the number line that corresponds to 2. So it's just a point. Now, these points make up other things. For example, we could talk about a line. And here we have this line right here. And you notice it has an arrow going this way, to the left, and to the right. And we just represent this line. Now, what a line is, it's all these points that are lying on a line. Okay? They're all going in the same direction. They're not curving or anything. So when we talk about a line, we're talking about all the little points that we stack together that are all following a what we call a linear path. Okay? And it's just like what you think about when you think about a line. Of course, this is a curve. This is a line, right? Because everything is following this linear path. Now, it's kind of like I'm describing a line with that word. But intuitively, you know what a line is. And we put two little arrows on it to indicate it goes on forever and ever. Now, if you give me 2 points, there is exactly one line that can go through that. So we've got this point A and we've got this point B. Generally, that's how we will denote a point. And we would refer to this line as A, B with a little arrow, two-way arrow above it. And that tells the reader that you're talking about a line that passes through point A and B. Now, you don't have to, this is very important, you don't have to go A, B. You could go B, A. And that would still refer to the same line. So if you think about this line, you've got AB, you've got BA, and you've got also this L at the end. Sometimes a line is referred to just by, a little lowercase cursive letter like that. Doesn't have to be cursive, but there it goes. So those are 3 ways we could refer to this line. Now, we also have plane. So here you have a point. When you add up when you put all these points together to make a line, we talk about a line. This line passes through point A and point B, and then we talk about a plane. Now, when we talk about a plane, you can think of it as just like a flat surface, like a table, a book, top of a book, something like that. And the thing about a plane is just like 2 points determine a line, 3 points determine a plane. And it's got 2 dimensions. So let's think about how we would name this plane. So here's the deal. 2 point. Think about this. Here we've got points. 2 points determine exactly one line. So there is exactly one line that passes through A and B. As far as a plane goes, 3 points that are not on the same line, that determines a unique plane. So notice this plane right here. We've got the points A, B, C. They're all on that plane. So we could name this plane ABC. Now we could also name it BAC. No worries there. Or we could name it CAB. Really, the order doesn't matter. Or we could name it M, like right here. Now, M is not a point there. So, in other words, different ways that we can name that plane. Okay? So, we've got points. That's the most basic. Line, that's next, and then the plane. Okay? Now let's look at this example over here. It says give 2 other names for PQ. So we're learning now just to read what we have here. We have give 2 other names for PQ. Okay, this line PQ. So PQ, that's this line right here. So we could name it N, this thing right there, or we could name it QP. Yeah, that's it. QP, like that. Okay, that's part A. Now, name 3 points that are collinear. Now, here's what it means by collinear. It means that they are on the same line. If points are on the same line, we refer to those as collinear. So let's look at what we have here. Collinear, we need name 3 points that are collinear. Well, look here. Here's SPT. SPT. Those are 3 points that are collinear. They're all on the same line. So when we say collinear, that's all it means. Coplanar, you're looking for points that are on the same plane. So let's take a look at this. Points that are on the same plane. Okay? So let's see here. The SPT, those are all on the same plane. Notice Q is not on that plane. Q is not on there. VSPT. Okay? So VSPT. Those are all points that are on that same plane. Okay, so we got points, lines, and planes. Now let's look at the next part. Okay, so we've got a line here. Now, let's suppose that this line does not go on forever to the left and right. Infinity. It's not an infinitely long line like the number line. Let's suppose we cut it off. We cut it off here at A and B. Then what we get is a segment, a line segment. And the way we would denote a line segment is very similar to the line, except we don't put the arrows on the left and right. Okay? So this would be AB or BA, depending. Okay? So it's different. Now, that is a segment. And notice a line segment has a beginning and an ending point. Okay? And it doesn't go forever to the left and right. Okay? Now, let's look at the next thing, which is array. Look at this. With array, it has one endpoint, like here. It starts at A, it goes through B, but it goes on forever. We would denote this as AB with a little arrow above it. This is a ray. So this one is starting at A and it's going on to infinity. This one down here, it starts at B. So I'll put B first, and it goes on forever through A. So now, these are rays. Okay, so let's see how we could use this information. So we're over here on this example 2, and it says, give another name for GH. Okay, so this line segment right here. Well, GH, that could be HG. Okay, so there's no problem there. Now let's look here at part B. Name all rays with endpoint J. Okay, which of these rays are opposite rays? Now, I haven't really defined what we mean by opposite rays, but let's look at this. Let's name all the rays with endpoint J. Okay, so we're talking about J right here. Okay, so this would be JE. Okay, so JE. Now let's look at another one. JF. Got to put my rays on here. There we go. JF. So JE and JF. And then what's next? JG. JG. And then JH. There we go. That's it. Now, you notice something here that I haven't taken note of yet. This JE and JF, JE and JF, those are running along the same line, right? They're running along the same line, they're just going in different directions. But they're contained in the same line. In other words, these are both part of the line EF. Okay, we get those from there. So, in other words, they're going in exactly the opposite direction. So we call these opposite rays. Opposite rays. And these ones here are also opposite rays. JG right there and JH, opposite rays. Yeah. Okay, now that's about it for that section. I just want to remind you of some things, though. Sometimes you'll see something like this. Just remember back when you first studied lines. Let's suppose we've got a line like this. Let's suppose we've got 2x plus 3. And let's suppose that we want to know if, for example, this point right here is on that line. So we have a relationship here. This is a line, and we want to know if this point is part of that line. Well, how do we determine that? Well, we put the y, here's a 5. We put that in for the y. And then over here for the x, we put in the 1. And we see if these two sides are equal. 5 equals, 2 plus 3, that's 5. So yes, these are on the same line. Or that point is on that line. Now let's look at this same thing. Here we have 2x plus 3, and let's look at this point, 2, 7. So let's see if that one is. So I'll put a 7 over here, 2 times 2 plus 3. Okay, so that's 7 equals 4 plus 3. Ooh, that's 7 as well. That point is on that line as well. Okay, let's look at another one. Y equals 2x plus 3. And I'm going to have 2, 8. Something like that. Okay, let's see if that works. 8 equals 2 times 2 plus 3. 8 equals 4 plus 3. 8 equals 7. No. So that point, 2, 8, is not on that line. Okay? So that's one of the types of problems that you'll be asked to deal with. Now, another thing. Remember back years ago, you worked with number lines, and you were asked to represent things like this. Let's suppose you've got x less than or equal to 5, and you want to represent that on a number line. Okay, so here is a 0, well, let's do this. Here we go. So let's just see how we would do this. We have, here's a 0, 1, whoops. 1, 2, 3, 4, 5. And we want to represent this thing, x less than or equal to 5. What we would do is, we have the endpoint there. We scribble that in, and we go to the left, just scribbling it in and making an arrow. That's sloppy, right? But really, you're just going like this. And here is 5. Okay, 5 like that. Now, let's suppose that we have something like x is between -3 and 6, like that. Well, how would that go? And we just want to represent that. Now notice this one, x less than or equal to 5, that goes on forever. Every number less than or equal to 5. This one starts at -3 and it goes to 6. So it's like this, and then of course it goes on, the number line goes on forever. But this would be the representation of that. Okay. Now we could also say, well, what about x greater than or equal to 4 or x less than or equal to -1? Well, what would that look like? Well, we have, there's 4. It goes on forever. Here is negative 1 over here. And it goes on forever. So, it would look something like this. But let me scribble it in. Okay. So it would look like that. Okay. So we kind of darken up to the right and to the left. Okay. Okay. Now, I've got the assignment here so y'all can work on that, and I'm available if you have questions. But anyway, the assignment's down here. I've got some problems cut out, copied and pasted from a textbook. So you can work on those.